Welcome to the Virginia Education Center for Asphalt Technology. My name is Todd Mansell. Today we'll be talking about paver operations, mixed delivery. So the role of the paver is to meet our specifications for grade, texture, and smoothness. So we want a smooth mat at the right thickness that looks nice and uniform from one edge to the other. If everything's set up properly, the mat texture from left side to right side should look the same as you can see in the left-hand picture here. We don't want to see different mat textures and thicknesses from one side to the other. How does mixed delivery produce a quality mat? The two big things are continuous non-stop paving and trying to avoid or at least minimize segregation in the mix. So mixed delivery to the paver, there's really four things I kind of think of. One is planning and setup. Number two is loading our trucks at the plant. Number three is the truck exchange at the paver. So whether we're dumping directly into the hopper from the trucks or whether we're using an MTV or material transfer vehicle. On the paver, we've got the tractor. That's really the material feed system. So the tractor receives the mix in the hopper. Again, whether it's directly from trucks or from a material transfer vehicle, the mix comes into the hopper. It's conveyed back to the screed on the conveyors that have feeder bars on there to actually move the mix. Adjustable height augers back at the screed, and then feed sensors that are not shown in this picture that control the head of material or the amount of mix back at the screed. So project planning, we look at asphalt tonnage, we'll look at our paving width, we'll look at our specs so we know how wide, how thick we're paving, what the cross slope or percent crossfall is, and we look at grade conditions when it comes to project planning. So these four things we really need to look at and think about ahead of time before we actually get out on the job and get ready to set down and start paving. So in terms of tonnage, so that's what our estimators bid the job, so many tons per shift. That's how we as a company end up making our budget and making some money and still doing a quality job. So with tonnage, we've got the output of the hot plant. So what the plant can put out, the length of the haul, so how far is it for the trucks from the plant to the job site, and then back to the plant again. Traffic conditions are always a big deal, especially when we get into urban areas. That's why we do a lot of night paving nowadays, just to avoid traffic disruptions, and quite often it helps in terms of our cycle times getting trucks from the plant to the job site. Maybe a lot faster at night when traffic isn't so bad. And the number of trucks is the other big thing when it comes to our tonnage. So the plant puts out so many tons, we've got to have the right number of trucks to haul that mix from the plant again to the paver. So the real key here in the planning end is balancing paver and roller speed. So again, based on our hot plant output and the rate of mixed delivery to the job site. So those two things are what we're going to plan our paver speed and roller speed around. And for quality, again, the goal is continuous paving. So the fewer stops we have with the paver, the better quality mat we will end up with. So the planning part really, it only takes maybe 20 minutes. And on the slide here is just showing some different tools that are available to help you in the planning process. You don't need any of these tools. They just make life easier when you take a certain tonnage and paving width and want to calculate number of trucks needed and paver speed. So you'll see NAPA, National Asphalt Pavement Association, has a publication, IS 20, Information Series 20, that has worksheets that go through taking a certain tonnage per shift. Just for example, say it's 2,000 tons. A paving width, whatever, again, it may be 12 feet, 2 inches thick. And you use those inputs and the output of the hot plant, so the Mix hop plant will be able to tell you how many tons per hour they can deliver, whether it's 200, 300 tons per hour they're able to deliver to your job. So we take those inputs and we'll calculate paver speed and roller speed. There's an app for everything nowadays. So if you do some Google searches, you'll find some apps for paving production calculator and cooling rates of the mix and all that also factor into our calculations on paver speed and roller speed. So I'm not going to go into a lot of detail here. I just want to give you a flavor on the planning end. So again, continuous paving is our goal. So to do that, we want to balance our plant output, so however many tons per hour we can get from the plant, our trucking, our paver speed, and our roller speed. So as an example, this job, 2,500 tons per day is what the estimators bid. The plant says they can deliver that. We've got an 8-hour paving window. We're using end dumps, 18-ton capacity on average for each one of those end dumps. We're paving 12 feet wide. It's a 2-inch overlay. It's a 12.5 millimeter or half-inch polymer modified mix. It's in the fall of the year, so temperatures are less than 70 degrees, so the mix will cool a little faster. And in this example, we're given 3 different rollers. An 84-inch wide steel drum roller, 79-inch wide steel drum roller, and an 82-inch wide pneumatic or rubber-tired roller. So we really need 7 pieces of information to calculate that balanced paver speed and plant and everything in balance. So we'll take our tons per hour and our silo capacity from the plant. That's pretty easy to get from the plant people. The paving window, so that's our actual paving hours. So again, this example, we picked 8 hours. That does not include our traffic setup and takedown time, so it's 8 hours of actual paving time. Average truck capacity, truck cycle time, that's easy to get. You just, foreman, superintendent, somebody drives the job from the plant to the job site, back to the plant. That's our cycle time. It will vary throughout the day depending on traffic. Mat thickness, or loose mat thickness, that's easy to figure out, or mat width, we know that from our job specs. Probably the hardest information to get is number 7 there, the loose mix density. And that you'll be able to get from the laboratory asphalt lab or the plant people as well. So many pounds per cubic foot. So we use the NAPA worksheets, or the picture you see on the slide here is just using an app. So we put those inputs in there first of all to figure out the number of trucks that we need to deliver 2,500 tons of mix in our example to that job in an 8-hour paving window. So again, it assumes 8 hours continuous paving to get rid of 2,500 tons of mix. So we need 20 trucks is what it comes up with on our calculator. Again, I could figure this out, scratching it out on a napkin and doing some hand calculations, but the apps or the worksheets make it easier. The next tab on this app you'll see is paver speed. So again, using those inputs that we already know, it's come up with the paver speed using end dumps of 36 feet per minute. So again, that's 2,500 tons over 8 hours of continuous paving at 36 feet a minute. We'll get rid of that tonnage with nonstop paving. Now, I call it perfect world paving because in the real world, we all know we will have some stops in there. But if we set a paver speed, a target, or a goal like this and try to maintain that, we will end up with a lot better quality mat at the end of the day. In this example, we're using what we call 75% efficiency to come up with that 36 feet a minute. So that means in between trucks, the paver will stop. So 75% really means that if we have a good end dumping operation, which we'll talk about later, where the truck comes to the paver, unloads, next truck comes in, we should actually be paving 45 minutes out of an hour if we have a good, smooth operation going. So trucks coming to the job, paver stops in between trucks, but 45 minutes out of an hour, or 75% of the time, we're actually paving, or the paver is actually moving. The only other number you see on the screen there at the very bottom in yellow is 29 feet per minute. That would be 100% efficiency, so the paver never stops. That could be a scenario with an MTV, material transfer vehicle. And we'll talk a little bit about those later as well. So that was kind of a preamble, but that's on the planning part of mixed delivery. So we want to set a target paver speed for our job, number of trucks, all tied to the number of tons per hour that we are getting from the plant. So we balanced everything, plant production, trucking, and paver speed. So why is speed so important? Speed of the paver, variable speed, affects our mat thickness. So when I slow up and the mat gets thicker, if I speed up, the mat gets thinner as that screed drops. So constant speed, again, if you remember from earlier courses, is critical to maintaining a quality mat. And this is just a quick review on that. Constant speed, mat thickness stays constant. Increased speed, the depth of our mat will decrease if we don't change anything else, if we don't change our mix feed. If I decrease speed or slow that paver down, more resistance on that screed, the mat thickness wants to increase. So again, paver speed, constant paver speed, very critical to a quality mat. And that's why we calculate a paver speed and try to plan our mix delivery to the paver in a constant, uniform manner. So in the real world, when we get trucks backed up on front of the paver, the best thing to do here is don't panic. Stick with our target paving speed. In our example, was 36 feet a minute. And get rid of those trucks in an orderly fashion. So we actually want to get them spaced out, get them back to the plant, and then in a nice, evenly spaced loop between the plant and the job site. So paving speed, constant, feeder system set to match our paving speed. Changes in speed may require changes in our feed system to maintain that constant mat thickness. So now we've done a lot of the planning part. We've emphasized the importance of constant paver speed for quality. So truck loading at the plant, very important. If we're not getting good uniform truck loading at the plant, one of the most common things we see on the road is what we call end of load segregation. And it usually appears as in an equally spaced pattern, so truckload to truckload to truckload. Often has a chevron shape to it, most common with the larger sized mixes. A lot more prevalent with a 3/4 inch mix than with a 1/2 inch mix, just because the larger stone mixes tend to segregate a lot more easily. So at the plant, one thing we can do to help in terms of loading the trucks under the silos or under the plant is first drop at the front of the truck box, second drop at the rear of the truck box, and the third drop in the center. And what that does is it just minimizes the amount of aggregate or large stones rolling into the corners and the edges of the truck box. Because when those large rocks are in the corners and we empty or raise that truck bed to deliver the mix into the hopper of the paver or even into the MTV, what's the first thing that comes into the hopper? It's those large rocks, right? So it's very important, especially with the larger stone mixes. So 3 drop, if you had the large end dumps, you may do the same type of thing, only even in a 5 drop procedure at the plant. So it takes a little bit of training with the truck drivers to do this. It's not difficult, but a little training will go a long ways to producing a quality mat. This slide just shows the concept of segregation, the large rocks. Always want to roll to the edges of a pile. Doesn't matter if it's a stock pile or mix loading out of a silo into a truck bed. So again, that effect of segregation is magnified when we just do single drop truck loading underneath the plant. So the 3 drop method will really help with segregation with those large stone mixes. This picture is just showing the large rock being the first thing on the edges of the truck bed, and in the corners as that truck bed is raised to dump into the hopper. So again, you can see all the large rock in this picture. Toward the edges, and even on top, depending on how careful they are loading the truck at the plant. Sometimes the goal on the plant operator is to get the maximum load in that truck, so they're hauling a full load, so to speak. And sometimes you'll see the plant operators chattering the gates, if you will, of the silo just to let a little bit of mix, a little bit more into that truck bed, but quite often it's just big rocks coming out of that silo when the gates or silo gates are chattered like that. Another thing on mixed delivery in terms of temperature are tarps. Very important. They help a lot retain heat, especially in the cooler times of the year when we really need to maintain that mixed temperature on the job site. Depends, how long our haul time is and all that. On the left side picture here, you can see what I would consider a good tarp on that truck. A couple things to note there. The tarp fits tight all along the sides of the truck in that left-hand picture. It also fits nice and tight at the front of the truck bed. And that's really important because on the right side, you'll see that tarp is raised or higher at the front of the truck. When that truck's going down the road, the 1 foot gap or whatever at the front of the tarp is just like a wind tunnel. So the air comes under there, literally funnels underneath that tarp and actually can cool that mix faster than if that tarp wasn't even on there in some cases, because it's just acting like a wind tunnel. So good tarping, there's poor tarping. As far as material goes, I tend to prefer the canvas tarps. They're a little heavier and they actually kind of sit on the mix and just retain the heat a little better than some of the other materials. Trucking mat defects can be caused by the paver truck interface. So again, mixed delivery here is what we're talking about, and a constant paver speed. So training is key to preventing defects related to the mixed delivery or trucking. We don't always do the best job of training truck drivers, do we? A lot of times we just kind of like to bark at them when they're not doing things right, but we don't spend the time to show them or tell them what we want. Truck alignment with the paver. So you want to align the truck to fit the situation. So the center of the hopper is the best for steering control on the paver. Depending on the cross slope that paver or the mat being paved is at, you may want that truck kind of to the high side of the hopper. So once that mix is emptied from the truck bed into the paver hopper, gravity is going to want to take control of that mix. So we may want to have that truck a little bit to the high side if we're paving on a cross slope. So just things to think about. But we don't want the truck box touching the hopper edges. Otherwise, it's going to be really difficult for that paver operator to steer the paver. Another common thing that we see if we haven't trained our drivers properly is the paver should always pick up the truck. So the truck should stop short of the paver, and then the push rollers on the paver keeps moving, and the push rollers will pick up the truck as opposed to that truck backing up and bumping into the paver. So this picture shows what happens to the mat, where the screed digs into the mat when a truck backs up and hits the paver. It forces the screed back. That bump you see in the picture here, not likely going to come out even after rolling. So it ends up being a bump in the mat when the truck backs up into the paver. So the paver moves into the truck. You've got a dump man shown in this picture. He's giving signals to the truck driver when to stop. So that truck will stop. The paver will move and actually pick up that truck. Some pavers have truck hitches on them. So in this picture you can see the hitch. Those are out wide once the paver picks up the truck and those push rollers touch the rear tires on the truck. The hitch is hydraulic, extendable in and out. It'll come in and kind of lock in on those truck rims. A lot of drivers don't like truck hitches because they scratch their rims and things like that. They're not always necessary. I see a lot of successful paving operations that don't use truck hitches, but you have to train the drivers to use light brake pressure so that truck won't roll away from the paver while it's transferring the load from the truck into the hopper. This picture, you can see what happened. Truck rolled away from the paver, and we've got a very unhappy crew. So we want to use clear signals. So again, you got to dump, whether it's a dump person there giving signals to the truck driver, or in a lot of cases it's the paver operator giving signals to the truck driver when to raise the bed, apply brake pressure and all that. But good communication and training is really key to a good truck exchange and mix delivery into the hopper. Here they're cleaning up now, so that truck rolled away from the paver, dumped the load on the road. Thank goodness they had a skid steer on the job instead of having to shovel it all. So they're cleaning up that mix now, but what's happening? Well, that paver's sitting there and they're cleaning up all this mix. That mix behind the paver's getting cold, the screed's settling into the mat. We're going to end up with a bump there for sure. We're going to have some lower density there where that mat got cold behind the screed. Probably not going to have a perfect cleanup here, so we'll pave over top of that and likely have some lower density areas as well. So just a lot of problems if we don't do the proper training and have good, clear communication with the truck driver. This slide just shows a temperature effect due to a long stop. So again, if we have a long paver stop during our mix delivery because of something like a spill or just a long waiting period because we got rid of a whole bunch of trucks and now we're waiting for trucks to come back, you can see, again, the big temperature differential here. It's going to be a difference in density once we get going again because of the temperature difference, colder mix behind the paver or where the screed was sitting, and the hotter mix again once we get started up. So we're going to have lower density, probably going to have a bump there. Real goal here is to try and keep any temperature differentials less than 25 degrees. When we're less than 25, good chance we'll be okay on density and smoothness. This picture, a little difficult to see, but there's a mark from the screed settling due to a long paver stop. So again, that may or may not roll out when the rollers get to it. Depends how long the stop is. Generally, if a paver stop is less than 5 or 6 minutes, it's not a big deal. It's when we get those longer stops, more than 5, 6 minutes sitting there, it'll leave a big enough bump and a large enough temperature differential that we're likely going to end up with some sort of bump there. So controlling the truck dump, release the tailgate, raise the bed to create a surge of mix into the hopper. So the key here is we don't want to dribble mix. Remember, all the large stone kind of rolls to the sides and edges of that truck box. So if we raise it too slowly, we're just going to get a bunch of big rocks coming into the hopper to start with. So we want to try and get that mix, raise the bed fairly quickly, get that mix to move in a big mass. In this picture, the dump person's giving signals to the driver to raise the bed. He'll let him know when to stop when he sees that big mass of mix moving into the hopper. And then to empty that truck at some point, we'll increase the angle and empty the rest of that truck into the paver. So this picture is just showing what happens if we dribble or raise that bed really slowly. We're going to dribble mix into the hopper. It's going to be more prone to segregation. And that cooler crust, you can see that forms on the outside of that mix in the truck box. The thermal image shows those cooler areas. It won't mix in as well when we raise that roll slowly. We'll end up with cold chunks in there and some cold chunks going through the paver and onto the mat. And quite often those are the areas that are more prone to raveling later on. So another thing is the bed length on the trucks. Most people end up running into this problem at some point, but some truck configurations don't extend into the hopper very far. So you'll get spillage on the grade. You can see in this picture, if you look closely, mix spilling onto the grade in front of the paver when that truck bed's raised up. So in that case, you just need to minimize the dump angle. Ideally, we want a truck configuration and adjust those push rollers on the paver so that we don't end up with that spillage and the flashing on the paver hopper. This guy in the picture here, he's using a shovel to kind of block some mix from spilling onto the grade, again, just because it's not the best setup for the truck bed fitting into the paver hopper. And this is something that really goes to the planning part as well, something to look at and hopefully plan ahead of time before the first day of paving. Whoever our trucking company is, or whether it's our own trucks, just make sure that the truck beds are going to fit nicely into the paver hopper. Or on the paver, again, those push rollers are adjustable, so we may adjust those so that the trucks fit better into the hopper. Another big thing with mixed delivery on trucks is staging those trucks. So in this picture you can see one truck. This is a live bottom, but you can see that truck is delivering mix into the hopper right now. And if you look ahead, you can see two more trucks at least ahead of that are staged and ready to back up to that paver once this truck is empty and leaves the job. So getting those trucks staged, again, all goes back to training, but we want to minimize any delays. We want to try and keep that paver moving as much as possible. Trucks entering traffic, so again on mixed delivery, some areas traffic's really bad. We could be waiting a long time with that paver stopped just to get trucks in and out of the job site. So some jobs, it's nice to have a traffic coordinator. Some jobs it's actually required, as you'll see in this picture. This guy is here stopping traffic so he can let the trucks in and out in front of the paver so that they can try and keep that paver moving. Another big thing once the truck's empty out is having a clean out area. So there may be a little bit of mix left in the truck bed. Most of us have all heard the trucks bang the truck bed at the end, pull in front of the paver a little bit away from the hopper, and then bang their bed and dribble and spill that bit of material on the grade in front of the paver. Not a good thing. That mix cools quickly. We'll end up just paving over top of it. Good chance it could end up being a bump. Probably going to be low density and an area that may ravel later on. So have a clean out area. It gets rid of that truck quicker as well, and we can clean up that pile, take it back and recycle it. So in terms of mixed delivery, align trucks to match the situation. So again, if it's on a bit of a slope or crossfall, you might want to have that truck lined up a little to the high side of the hopper so that mix fills the hopper as much in the center as possible. Truck always stops short of the paver, never back into the paver with the truck. Use a truck hitch to maintain contact. Not always necessary, but sometimes a nice feature to use. Lock that truck to the paver. Driver applies light brake pressure to maintain contact of the truck with the paver. Keep the bed raised when dumping, so we want to raise the bed fairly quickly and let a big mass of mix move into the hopper at one time. Try not to make small incremental raises in the truck bed where we're just dribbling mix into the hopper. Stage trucks so that we can minimize the length of time for any paver stops in between trucks. Provide a designated clean out area, not in front of the paver, somewhere off to the side. And maybe think about a traffic coordinator to help trucks get in and out in front of the paver, depending on traffic conditions. So that's some of the things with mixed delivery, the truck exchange. So we talked about truck exchange at the paver already a little bit, but what I'd like to cover now is really a 4-step procedure. So taking some of the things we just talked about, but kind of summarizing it into 4 steps. So truck transfer into the hopper is still probably the most common practice, directly from the truck into the hopper. If we look at a 4-step routine, we've got the paver operator or dump person and the truck drivers all need to work together. So step 1. So we're paving along, the truck bed is raised, mix is already flowing into the hopper. That's where we're jumping into this process. So once the truck bed's empty, paver operator or the dump person's going to signal that driver, we're going to release that truck, let them go. Truck's going to lower the bed and pull away from the paver. The paver here in step 2 is going to just continue paving at normal speed as that truck pulls away. So we're going to pave until the level of mix, that mix level in the hopper, goes down far enough to allow us to cycle or fold those hopper wings. So we don't want to fold it right away when that hopper's full, or we're going to spill mix in front of the paver onto the grade. That's not a good thing. That'll get cold, it won't compact properly. So let the mix go down a little bit, fold the hopper wings if it's permitted. There are actually some jobs that will not allow folding of the hopper wings. It can, if it's done properly, it's usually not a problem, but most common time, or when we really want to be careful about folding hopper wings, is again with the larger stone mixes. We have to really be careful with those 3/4 inch or 1 inch large mixes. 1/2 inch, we still have to be careful, but maybe not quite as obvious as far as segregation goes. So folding the hopper wings, while we're doing that, again, the paver operator's got to be very careful to make sure material or mix isn't spilling in front of the paver. So you got to be paying attention here. We also don't want that hopper to get low enough where we can see the slack conveyors or the bottom of the hopper. So step 3, we're cycling the wings, not spilling onto the grade. This way we're combining mix into the middle over top of the slack conveyors and still paving. Little bit of spillage starting there. Again, that's what we want to try and avoid. So at that point, that's when the paver operator is going to start lowering the wings again and get ready for that next truck to back into the paver hopper. And this slide just shows why we want to avoid spilling mix on the grade. We've got cold mix just under the surface if we spill it on the grade. The mat may not show any visual defect. We'll pave over it. It'll look just like the rest of the mat, but that cold mix causes temperature variations. It's a lot colder because it was spread out, dribbled, if you will, or spilled. So it's cold almost instantly. We pave over it, doesn't look any different. Thermal camera picture really shows the difference. And again, once we compact it, because it's a low density area, because it was cold, good chance it's going to lead to raveling, might pop out a year from now where the rest of the mat looks fine, and also could end up being a bump in our mat there. So again, cycling the hopper wings on some jobs, especially the 3/4, 1 inch mixes, may actually be prohibited, or you just may decide as a crew that you don't want to cycle hopper wings with those large rock mixes that are a lot more prone to segregation. So the key here, whether you're folding the wings or not, is to make sure those slack conveyors do not get exposed. You don't want to see the bottom of the hopper, and you may have to occasionally shovel out the sides and get that mix in the center to move through the hopper. So again, we paved along, we've cycled the hopper wings, we've lowered the wings back down, as you can see in this picture, without spilling mix on the grade, and now we've stopped the paver. So we don't want to see the conveyors or the bottom of the hopper. So now we're stopped, the next truck is going to back in. This is what we do not want to see. So last slide, we got mix covering the conveyors, the truck will dump on top of it, life is good. If we didn't let it run down like this, you can already see the rocks that are resting or coming in from the sides now of the hopper. What's the first thing that's going to come out of that truck bed? Along the edges and the tailgate on that truck when it goes to dump. First little bit, no matter how good a job we do loading at the plant, it's going to be a little bit rockier than the rest of the mix. So now we've combined two things if we run that hopper low. We're going to end up with rock pockets on the roadway. Again, this slide just showing a poor truck exchange. They've let the hopper run too low. If you look closely, you can actually see air, see the tunnel where the conveyors go in there. You never want to see that. The mix is too low. It's going to segregate on the mat. Again, just another picture showing the mix running too low. You don't want to see the tunnels. Another common mistake that I see on paving jobs is, if you look closely at this picture on the left side, if you look back at the screed, you can see mix back there. They're paving along. That truck is now lowering the truck bed, getting ready to leave the paver. And then on the right side picture, you see the paver ran that mix or ran that hopper empty. But if you look back at the screed, you still see mix back there. And I see this a lot. So the operator ran the hopper empty, waiting for the next truck, but left a whole head of material back at the screed there. So now what's going to happen when the next truck comes, we're going to have a little bit of segregation going on there. The first material that comes in there is the first thing. The second thing is probably going to run a whole bunch of mix back on those conveyors now, so that when the paver does take off, there will be mix there. We basically just created a bump and a dip in our mat. So when the next truck comes, we run mix back, so we're going to have a big head of material. That's going to cause our bump. Our dip was just caused by no head of material because we ran that hopper low. So it's kind of a double whammy when we leave that screed full and run our hopper empty. This is just showing temperature variation, the effect on temperature when we run that hopper empty. So we'll get cold spots when we start up again. So a typical truck exchange, we're going to have what we call acceptable variation. I mean, it's not going to be perfect. There's always going to be a little bit of variation in temperature there. The key here is just quick truck exchanges. Exchange should take 1 to 2 minutes if we've got a good operation going. The screed marks from that short stop should just roll out. So with the truck exchange, there's that 4-step procedure. We want to pave at normal speed between trucks. Fold the wings every truck when it's allowed. If not, then we just make sure we leave enough mix in that hopper, at least a third to a half full, so that the next load will just dump on top of it and eliminate any segregation. We never want to pave out the material in the hopper, so we don't want to run that hopper down to where we see the conveyor tunnels or see the conveyors or the floor of the hopper. Cycle the wings when the conveyors are still covered with mix, and try and avoid those prolonged stops. So again, 5 to 6 minutes or less, not likely a problem, but when we get longer stops, it's going to lead to bumps or density problems. Kind of a final thing on mix delivery, material transfer vehicles. So we talked a lot about end dumping trucks directly into the paver. The other way of delivering mix to the paver is a material transfer vehicle. So some MTVs have remixing capability. Some are just simply what we call pickup machines or elevators where they don't remix. The picture here shows a remixing machine. It's got a surge capacity. So in this example, it may be about 1 truck load of surge capacity. So these are nice because the paver can keep moving while 1 truck empties and leaves the MTV. Another truck backs up to the MTV, but there's enough surge capacity in there where the paver can keep moving and the MTV can keep feeding that paver in between trucks. So they're nice for non-stop paving. This picture just showing a nice looking mat. We don't have any pattern or end of load segregation going on here using the MTV. Highly recommended for large stone mixes and some larger stone SMA mixes, stone matrix asphalt mixes. Just because those large stone and SMAs are a little more prone to segregation, the MTVs with the remixing capability can really help blend that mix nicer and avoid segregation. This slide just shows temperature differentials, so you're always going to get a little bit of temperature differential in between truckloads, or even with an MTV, if you let that hopper run too low, you'll still end up with segregation or temperature differentials. The key is to try and minimize anything more than 25 degrees difference. This slide just showing a thermal image of the mat behind the paver where an MTV has blended that material. The whole idea here is, again, the remixing does help with uniformity when it comes to temperatures and aggregate segregation. This slide showing some random patch segregation. So this appears in the mat without pattern, comes and goes, kind of difficult to pin down. It can be a mixed delivery problem, and that's why we're showing it here in this presentation. It's usually related, again, to those large stone or large aggregate mixes, end of truckload, that sort of thing. But it can also be related to the feed system set up on the paver. So in another training module, we talked about feed sensor positioning and continuous auger movement. This random patch segregation can be related to that, or it can be related to how we deliver mix into the hopper or the paver. So again, segregation showing up in random patches. Hopper insert, so with the MTV, again, they're not going to solve all our segregation problems by any means. We still have to use best practices operating an MTV. A couple of the main ones are if we have the hopper or using a hopper insert, so that'll help as opposed to dumping from the MTV directly into the paver hopper. We have to keep that hopper insert relatively full. So generally a minimum of half full to completely full for that hopper insert. Otherwise we'll still end up with segregation even with an MTV. When that level runs low, as you can see in this picture, even with a hopper insert and an MTV, we still have large stone segregating to the edges of the hopper insert, and that's going to travel through the paver and show up in our mat. So don't empty the hopper insert, don't empty the MTV. So the surge capacity in the MTV, the remixing chamber, if we let that run low, and again, generally about 1/3 to 1/2 is where we want to, the maximum, we want to let that hopper or surge capacity on the MTV run to. If it gets lower than that, we're going to end up with segregation. Drop height is another one. So with the transfer vehicle in this picture, you can see the conveyor that's dropping into the hopper insert at the paver is lowered as much as possible. And again, we're just minimizing the drop height here. If that conveyor is raised way up in the air, the mix drops off the end of that conveyor. The farther it drops, the faster it goes, and the more tendency it will have to segregate to the edges, even in the hopper insert, and then through the paver and onto our mat. So the key things with the MTV: keep the surge bin in the MTV at least 1/3 to 1/2 full, keep the hopper insert at least 1/3 to 1/2 full, and minimize the drop height from the conveyor into the hopper insert. So mixed delivery, preventing segregation. 3-drop truck loading at the plant. Discharge the truck properly using a 4-step procedure at the paver. Don't run the hopper low. Do not expose the slack conveyors or the bottom of the hopper. That means we're too low in the hopper. Don't fold the hopper wings when there's segregated mix in there. If we do have segregated mix in there, let the next truck dump on top of it before we move mix back to the screed. Load the paver using an MTV with remixing capability. That could help a lot with segregation, especially with the large stone mixes and some SMA mixes. But even with the MTV, don't run the hopper insert low. Don't run the surge bin or capacity remixing chamber low on the MTV. And keep the drop height low from the conveyor of the MTV into the hopper, and strive for a continuous paving operation. Again, non-stop paving. It's going to give us our best mat quality, best density, best smoothness. And with that, thank you for your attention today.